Welcome to Science Exposed, the show that digs into the coolest science stories out there. And we got to give a big shout out to Dr. Cameron Jones for finding these awesome topics. He's our curator, and he's got a real knack for finding the good stuff. Today, we're going deep on something that's really got us scratching our heads. It's a photo from 1913 with Albert Einstein at a tea party with three women who nobody knows.
Yeah, it's like a historical mystery novel. The identities of these women have been a complete puzzle for over a century.
Totally. And this wasn't just any old snapshot. This was at a big deal physics event at ETH Zurich, a prestigious colloquium. So the big question is, who are these women hanging out with Einstein? Well, get ready because we're about to solve this puzzle using a mix of history, open source intelligence, like real detective work and even a little bit of AI.
It's really amazing how these different methods can come together to give us a much clearer picture of the past.
Right. And it all started with some researchers doing a network analysis of Rebecca Alida Beagle, who is a Dutch astronomer and psychologist. It's kind of like building a scientific family tree.
Yeah.
They were tracing her connections to see who she knew, where she worked, and what events she attended.
Network analysis is a seriously powerful tool for historians. It helps us move beyond individual biographies and see the web of relationships that shape scientific communities.
And in this case, it led them right to this super interesting photo. Now, to be fair, this wasn't the first time people tried to crack this case. The Einstein Papers Project back in the 90s and science blogger Joanna Berman more recently both gave it a shot. But they only managed to identify 2 out of the 3 women.
Yeah, Berman figured out who Katharina Amelia Frankamp and Eva Dina Bruins were through some pretty impressive detective work. But that third woman, she remained a total mystery.
A true enigma. So how'd the researchers finally break through? Enter OSINT, or open source intelligence. Think of it like being a digital detective. You're combing through online archives, public records, even those shady corners of the internet we call the dark web, all to find information that's technically public but not easy to get to.
It's fascinating how OSINT can connect those seemingly random pieces of data, revealing hidden connections and shining a light on the lives of these people.
Absolutely. And to make things even more interesting, researchers also used AI, like facial recognition and age estimation software. But before you picture some sci-fi movie scene, remember, AI is just a tool. It has to be used responsibly, and you always got to double-check its findings with solid evidence.
Definitely, AI can give us some cool insights, but it's the human element, the critical thinking, and the careful research that really brings those insights to life.
Okay, so let's get down to business. How did they use all these tools to figure out who these mystery women were? Starting with Katharina Amelia Frankamp. They confirmed her identity using both good old-fashioned historical research and some clever OSINT work.
And what's really interesting is that Frankamp's life wasn't all about science. She was married to a well-known graphic designer and museum director. And get this, she actually shared a front door with Betty Beagle in Amsterdam. It's these unexpected connections that make historical research so captivating.
I know, right?
Yeah.
It's like putting together a puzzle and finding a hidden message within the image. And speaking of Betty Beagle, her name keeps coming up. What about the second woman they identified, Eva Dina Bruins? Where does she fit into all of this?
Well, they figured out who Bruins was using similar methods. They found her connection to the VVSL, which was a women's sorority in Leiden, and they discovered she shared a passion for astronomy with Betty Beagle.
Hold on a sec, VVSL, was that just a social club or was there more to it?
The VVSL, which stands for Vereniging van Vrolijk Studenten te Leiden, was way more than just a social club. It was a place for intellectual exchange where women could pursue their academic interests, challenge those societal norms, and support each other. Remember, this was the early 1900s, a time when women in academia were often seen as out of place.
So the VVSL was a crucial link for these women. It helped them connect and grow intellectually. That's amazing. But let's get back to the mystery. We've identified 2 of the women, but what about that elusive third one? Researchers must have hit some roadblocks, right?
Oh, they did. In fact, they first thought it might be Sophie Rotzan or Tatiana Alexievna Afanasieva. But using age estimation software and carefully analyzing historical records, they ruled both of them out.
So who is the third woman? The suspense is killing me.
Well, all signs point to a familiar name, Betty Beagle.
Betty Beagle, of course. It's like she's at the center of this whole network.
Hmm.
But what evidence led them to think it was her?
Remember those strong network connections we talked about? Well, Betty wasn't just a member of the VVSL. She was the leader. She was a huge advocate for women's rights at the university and had a deep passion for astrophysics. Plus, she shared an academic background with both Frankamp and Bruins, and they became close friends later on in Amsterdam.
Okay, so that's a pretty good start. But was there anything concrete to back up the idea that Betty was the mystery woman in the photo? I mean, sharing a passion for astronomy and having some social connections isn't really proof, right?
You're right. We need more than just circumstantial evidence. And that's where Betty's unique skills come in.
Okay, I'm all ears.
Yeah.
What skills are we talking about?
Remember those Reschenpferd, the calculating horses that Einstein often relied on? Well, it turns out Betty was a master of complex calculations. Researchers found evidence of her work for Carl Jung involving some seriously intricate astrophysical data.
Wait, are you suggesting that Betty, with her math skills, could have been one of Einstein's calculating horses? Maybe even contributing to his groundbreaking theories?
It's definitely a possibility. And remember, Einstein was known for his collaborative spirit. He surrounded himself with talented people who could help him, and Betty definitely fits that description.
Wow, that's mind-blowing. So we have Betty's network connections, her leadership role in the VVSL, her shared academic background, and now this revelation about her calculating abilities. Starting to look like a pretty solid case, wouldn't you say?
It's a compelling picture for sure. But there's one more twist to this story. A mysterious man lurking in the background of the photo. Initially mistaken for a Dutchman, he turned out to be Johann Jakob Kern, an Austrian physicist with a fascinating connection to Paul Ehrenfest.
Hold on, who's Paul Ehrenfest? And why is this connection such a big deal?
Ehrenfest was a famous physicist and a close friend of Einstein's, and here's where it gets interesting. Kern and Ehrenfest weren't just colleagues, they were childhood friends. Classmates at the Akademisches Gymnasium in Vienna.
Okay, that's pretty cool.
Yeah.
A childhood friendship that turned into a lifelong bond in the world of physics. But how does this tie back to our mystery woman, Betty Beagle?
It adds another layer of intrigue. Researchers found personal letters between Kern and Ehrenfest, revealing a deep and lasting friendship. And we know that Ehrenfest was at the colloquium where the photo was taken.
So it's possible that Kern, through his connection to Ehrenfest, was also connected to this group of scientists, including Betty Beagle. But how did Kern end up in the photo with Einstein and the three women?
That's a great question. It seems Kern was more than just Ehrenfest's friend. He was a talented physicist himself, attending colloquia, contributing to research, and making his own mark on the field. It's possible he was invited to the tea party because of his own work, or maybe because of his close connection to Ehrenfest.
It's amazing how this investigation has not only solved the mystery of the women in the photo, but also uncovered a hidden friendship between two physicists and shed light on Kern's own role in the scientific community.
It highlights how each individual within a network has their own story, to tell a story that can enrich our understanding of the broader scientific landscape.
Absolutely.
Right.
But before we get too caught up in the individual stories, let's take a step back and talk about the bigger picture. This whole case hinges on the power of network analysis, right? Can you explain a little more about how this approach is changing the way we study history?
Network analysis lets us see history as a web of interconnected relationships instead of a bunch of isolated events. It helps us understand how ideas spread, how collaborations form, and how individuals influence each other. In this case, the VVSL stands out as a key point in the network, a central hub that connected these pioneering women and helped them grow both intellectually and personally.
It's incredible how a seemingly simple photograph can unravel such a complex and fascinating tapestry of connections and stories.
It really shows how interconnected history is and how important it is to look beneath the surface to uncover those hidden stories.
And speaking of stories, this deep dive really challenges the stereotype of women in early 20th century science as passive observers. These women weren't just canopy angels, as some might have thought. They were active participants, attending colloquia, conducting research, and supporting each other.
They were brilliant minds, actively shaping the scientific discussions of their time. It's crucial that we recognize their contributions and make sure their stories are told.
Absolutely. But before we wrap up this part of our deep dive, I have one burning question. How do we know for sure that this photo was actually taken in 1913? Could it be from a different year?
That's where the real detective work of historical research comes in. We have to carefully examine all the evidence and put together a timeline.
Okay, let's break it down. What clues do we have?
Well, one clue comes from a letter that Einstein wrote to Paul Ehrenfest in May of 1913. In the letter, Einstein mentions that he heard from one of the Dutch women visiting Zurich that Ehrenfest was planning to visit. Since Ehrenfest is in the photo, we can figure out that it was taken sometime after May of 1913.
So that narrows it down a bit.
Yeah.
But we still don't know the exact date. What else can we use to pinpoint the time?
Remember that postcard Einstein and the other colloquium members sent to Leonid Mandelstam? The one with the signatures of all three Dutch women?
Oh yeah, you mentioned that before. Didn't they send it from Zurich?
They did.
Yeah.
And that postcard was sent in June of 1913. So now we know the photo was taken sometime between late May and June of 1913.
Okay, we're getting closer, but can we get even more specific? Like down to the actual day?
We can. Thanks to Aaron Fest's diary, he was meticulous about keeping it. In an entry dated June 30, 1913, he mentions a gathering with Weiss and Kern and notes that photographs were taken. He even wrote down the exact time, 4:30.
Wait, are you serious? We actually know the precise date and time this iconic photo was taken. June 30, 1913, at around 4:30 p.m. That's incredible.
It's remarkable how seemingly small details like a diary entry can unlock such a precise historical knowledge.
It's like we've traveled back in time and witnessed this moment firsthand. We've identified the women, we know exactly when and where the photo was taken, and we've even explored their connections to Einstein and the broader scientific community. Case closed, Ray.
You'd think so, wouldn't you? But there's one more layer to this story that I think you'll find quite intriguing. It has to do with why these three women were even at the colloquium in the first place. And it challenges what we think we know about Einstein's supposed genius in all things scientific.
Ooh, now I'm really curious. You've got to tell me more. Okay, spill it. What were these women even doing at the colloquium? And what's this about Einstein not being a math whiz?
Well, we know they were super into astronomy and astrophysics.
Yeah.
They studied under some big names like Alfred Wolfer, who also knew Einstein.
So maybe Wolfer introduced them, like an academic connection.
That's definitely possible, but here's where it gets really interesting. Einstein wasn't exactly a math genius. Now, before anyone freaks out, he was a brilliant physicist, no doubt. But when it came to super complicated math, he knew his limits.
So even Einstein had weaknesses. Makes it seem a little more human, huh?
Exactly. Even geniuses need help sometimes. He often relied on others to do the heavy lifting when it came to those really complex calculations. He even had a special term for them. Rechenfeld, which means calculating horses.
Hold on. Are you saying these women with their astrophysics background and their killer math skills could have been Einstein's calculating horses?
Yeah. It's a pretty fascinating thought, isn't it? Remember those calculations Betty Beagle did for Carl Jung? They were insanely complex, showing a serious level of skill.
That's wild. So these women, who are often left out of the history books, might have actually helped shape Einstein's groundbreaking theories.
It really shows how scientific progress is rarely a solo act. It's more like a symphony of minds working together, each one contributing their own unique talents and expertise.
And it just goes to show how important it is to look beyond those traditional narratives, to uncover the hidden contributions of people who might not have gotten the recognition they deserved.
Absolutely. It's about giving credit where credit's due and acknowledging that scientific discovery is a team effort.
Okay, so we figured out who the women in the photo are, we know exactly when and where it was taken, and we've even explored the idea that they might have helped Einstein with his work. But what about the Tea Party itself? Was it just a social thing, or was there more to it?
That's a great question. And while the sources don't come right out and say what the purpose was, we can make some educated guesses based on what we know about these people and why they were all together.
All right, let's put on our detective hats and speculate. What clues can we gather from what we already know?
Well, for starters, this wasn't just a random group of folks. These were brilliant minds at the cutting edge of scientific research, engaged in groundbreaking discussions and pushing the boundaries of knowledge.
So maybe this Tea Party wasn't just a casual get-together, but a chance for these great minds to connect, share ideas, and maybe even spark new research.
Exactly. These informal gatherings can be super productive. They create a more relaxed and free-flowing environment for sharing ideas without the formality of lectures or presentations.
It's like a scientific jam session where these brilliant minds could bounce ideas off each other and explore new possibilities.
And we know that Einstein in particular loved these kinds of informal exchanges. He believed that real understanding came from dialogue and debate, from the clash of perspectives and the synthesis of different ideas.
So this Tea Party, captured in that single photograph, could have been a breeding ground for revolutionary ideas. A moment where the seeds of future scientific breakthroughs were planted.
It's a tantalizing thought, isn't it? We might never know for sure what they talked about during that Tea Party, but we can imagine the intellectual energy, the passion for discovery that filled the room.
It reminds us that history isn't just about dates and facts, but about the human stories behind those events. The moments of connection and collaboration that shape human progress.
Beautifully said. And those moments, often hidden from view, are what make history so compelling.
Okay, we have dug deep into the mystery of the women, the purpose of the Tea Party, and even touched on Einstein's collaborative approach to science. But there's one more aspect of this deep dive that I find particularly fascinating, the innovative methodology used to solve this case. It's like a scientific trifecta, wouldn't you say?
Absolutely. The researchers seamlessly blended traditional historical research with open source intelligence, OSINT, and artificial intelligence, AI. Each method brought its own strengths to the table, making the others even more powerful.
Can we break that down a bit? How did each method contribute to solving this mystery?
Traditional historical research provided the foundation, of course. Researchers dug into archives, analyzed primary sources like letters and diaries, and pieced together a historical narrative based on solid evidence.
Right, that's the classic approach.
Yeah.
But how did OSINT shake things up?
OSINT took the investigation beyond those traditional archives. Researchers scoured online databases, public records, and even those shadowy corners of the internet we call the dark web, all to find information that might have otherwise stayed hidden.
So it's like casting a wider net, bringing in information from sources that historians might not have traditionally used.
Exactly. And then there's AI. It provided a whole new set of tools for analysis and interpretation. Facial recognition software helped confirm identities, while age estimation algorithms helped narrow down potential candidates and backed up findings from other sources.
It's amazing how AI is changing the world of historical research. It's like having a digital detective assistant helping us see patterns and connections that we might have missed otherwise.
But it's important to remember that AI is just a tool. It's the human element, the critical thinking, and the careful research that really make those AI insights meaningful and turn them into a compelling historical narrative.
Right, it's all about using AI responsibly as a way to enhance traditional research methods, not replace them. This case really shows how powerful it can be to combine these methods to shed light on historical mysteries.
Absolutely, and it opens up so many exciting possibilities for the future of historical research. Imagine all the hidden stories we can uncover, the narratives. We can challenge the understanding we can gain by using these innovative approaches.
It's like we're entering a new age of discovery, an age where technology allows us to ask new questions, explore new avenues of inquiry, and connect with the past in ways we never saw possible.
And it's an age where collaboration and interdisciplinary approaches will be key to unlocking the full potential of these powerful tools.
Speaking of collaboration, we haven't talked much about Johann Jakob Kern, the mystery man we identified earlier. What else could you tell us about him and his connection to Paul Ehrenfest?
Ah, Kern. He was more than just Ehrenfest's friend. He was a talented physicist in his own right. Their friendship, which went all the way back to their childhood, clearly had a big impact on both their lives.
Yeah, you mentioned they were classmates, but what can we learn about their relationship from the source material?
Researchers got access to their personal letters, and they show a depth of friendship that went beyond just professional courtesy. They confided in each other, sought advice, and even helped each other find jobs at universities. It was a friendship that stood the test of time and distance.
That's amazing. It seems Kern played a much bigger role in Ehrenfest's life than we initially thought.
Exactly. And Kern's own story is pretty fascinating. He was an active member of the scientific community, publishing papers, contributing to research, and attending colloquia, like the one where the photo was taken.
It's incredible how this deep dive has not only solved a mystery, but also revealed the hidden stories of people who, while not household names, played important roles in the world of science.
It's a reminder that history isn't just about the famous few, but about the combined efforts of countless individuals, each with their own unique talents and contributions.
And it highlights how interconnected scientific progress really is. Even someone like Einstein, often portrayed as a lone genius, relied on a network of collaborators and supporters.
Absolutely. He understood the value of teamwork and actively sought out people who could complement his skills. It's a valuable lesson for all of us, no matter what field we're in.
Okay, so we've identified everyone in that 1913 photo. We know exactly when and where it was taken. We've considered the possibility that these women contributed to Einstein's work, and we've uncovered the hidden friendship between Ehrenfest and Kern. This has been an incredible journey, wouldn't you say?
It really has. It's a testament to the power of curiosity, the thrill of discovery, and the importance of never stopping asking questions.
But before we wrap up this fascinating deep dive, I have one last question that's been bugging me. We've talked about Einstein relying on calculating horses for help with complex math. But why didn't he just learn the math himself? Was he just not able to grasp it, or was there something else going on?
That's a great question, and it gets at the heart of what genius really is. Was Einstein's brilliance limited to physics, or did it extend to math as well?
Ooh, now you've got me really curious. I need to know the answer. So, was Einstein just bad at math, or was there more to it?
It wasn't that he was bad at math. Einstein was a brilliant physicist, no doubt. His insights into space, time, and gravity totally changed how we understand the universe. But even he knew his real strength was in conceptual thinking. Visualizing those complex problems and coming up with those groundbreaking theories. Math was definitely essential to his work, but for him it was more of a tool, a way to express and refine those ideas.
So he was more of a big picture guy, a visionary who could see the whole forest, but maybe not every single tree.
Exactly. And that's where those calculating horses came in. They were the math experts, the ones who did those super precise calculations that let Einstein translate his big ideas into actual equations and predictions that could be tested.
It makes you wonder how many other brilliant minds might be hidden in the shadows of those big names in science. How many unsung heroes and heroines help make those breakthroughs that we credit to just one person.
It's a humbling thought, for sure. And it really emphasizes how important it is to recognize that scientific progress is a collaborative effort. It's rarely a one-man show. It's a whole orchestra of minds working together, each one bringing their own unique talents and perspectives.
This whole deep dive has really changed how I think about how science works.
Yeah.
I always imagine these lone geniuses working all by themselves, having those eureka moments out of nowhere. But it seems like collaboration and support networks were way more important than I ever realized.
You're spot on. Science is a social thing. It thrives on sharing ideas, rigorously testing those hypotheses, and everyone working together to learn more. And a lot of times, those big breakthroughs we credit to a single person are actually the result of years or even decades of people working together.
It makes you appreciate those unsung heroes, those calculating horses who maybe didn't get their names on the published papers, but whose work was just as important.
Exactly. It's about recognizing that scientific progress is a team effort, a tapestry woven from the threads of countless individual efforts.
This whole case really shows the power of using traditional historical research alongside those new approaches like OSINT and AI. It's like opening a door to a whole new world of possibilities for finding those hidden stories and challenging what we think we know.
Definitely. These methods can help make information more accessible, giving anyone with an internet connection the chance to be a historical detective. Think of all the mysteries we could solve, the connections we could make, the voices we could bring to light by embracing these new ways of doing things.
It's like giving a voice to the voiceless, bringing those hidden figures out of the shadows and into the spotlight where they deserve to be.
And it's not just about the past. These methods can help us understand what's happening today, too. They can help us understand those complex social networks, see how information spreads, and even fight back against fake news.
It feels like we're stepping into a new era of discovery, an era where technology gives us the power to ask new questions, explore new paths, and connect with history in ways we never thought possible.
Absolutely. And it's an era where working together and using a mix of approaches will be key to unlocking the full potential of these powerful tools.
So as we wrap up this deep dive into the 1913 Einstein photo, I have to say I'm filled with a sense of awe and wonder. We've not only solved a mystery that's been around for over a century, but we've also gone on a journey that's challenged our assumptions, broadened our understanding of history, and opened up all sorts of possibilities for future research.
It really shows the power of curiosity, the thrill of discovery, and why it's so important to never stop asking questions.
Well said. And with that, we want to thank you for joining us on this incredible adventure. Don't forget to like, share, and subscribe to Science Exposed for more deep dives into the amazing world of science. And be sure to check out the show notes for more on this episode, including links to all the sources we talked about and ways to connect with us. Huge thanks again to Dr. Cameron Jones for finding this amazing topic. Until next time, keep exploring, keep asking those tough questions, and never lose that sense of wonder.